Hello everybody, welcome for this Oracle Active Data Guard deep dive session, which is about best practices to optimize your disaster recovery strategy. My name is Peter van Pembroek, I'm Product Manager for Data Guard and Active Data Guard. First things first, safe harbor statement. Please read it very carefully. And then we continue with the topics of today. We are going to take a look about Data Guard, maybe some things you know or did not know from the past, as we are going to compare Data Guard against some competitive storage replication as well. Of course, your disaster recovery deserves the best things. So we are going to tell you what's Active Data Guard adding to normal Data Guard. So what basically comes extra with the product. A good disaster recovery mechanism also includes that you stay up to date with your versions. So we are going to introduce some 19C new features. And of course, at the end, we have the Q&A questions and answer, and I will make sure that we have some time for that as well. Oracle Data Guard is part of the maximum availability reference architecture, and it starts as an optional step for silver, but as soon as we go to gold, it's mandatory. And without saying, of course, platinum also includes Data Guard and Active Data Guard. The Oracle Maximum Availability Architecture is a bunch of customer insights, expert recommendations, and good and best practices that we have gained all over the years, which resulted in some blueprints, architecture blueprints, which go from bronze, silver, gold, platinum, and each of them consists out of different products that we have. Products being application continuity, Active Data Guard, Golden Gate, Flashback, RAC, and that kind of stuff. The moment you have chosen which protection level based on your RTO, RPO that you need, it comes with some products, and then we can go to choose our deployment options that we have. Even though Oracle Active Data Guard is a mature product, we are still constantly improving it. And that's something we do to protect your data in a simpler way and make sure that we can switch over and protect your data a little bit faster now and in the future. As you can see, I have listed a bunch of features in each certain version, but that does not mean that we are not evolving the product. So even in future versions, we keep adding features, and that's something we do by listening to you. So if you have good enhancements requests, please send them to me, and we will have a look, and maybe in future version, maybe your feature can be listed here as well. So let's dig into Data Guard. Something we often got asked is to mirror or to not mirror. That's basically a question. So storage replication does have its place in the landscape and in the architecture, but it's not meant for every single thing. So imagine a situation with more layers, virtualization, network layers, storage area networks, and that kind of stuff. It all contains software, and software might contain some bugs. An Oracle database, when it does a write to disk, it expects the write to happen and to be there. So the moment something happens in one of the layers between the Oracle database and the disk, yeah, it might result in a corrupt block. And that means that when you're replicating that full storage, there is no validation of the Oracle database block. And that gets replicated to the disaster recovery site, which turns your disaster recovery site completely unusable. So if we have a look and we take how storage replication works, we see that all the database files are replicated to the standby disaster recovery site, but also the read logs, which tend to change a lot, are forwarded to the disaster recovery site. That means that we are doing a lot of network bandwidth from primary to standby. Also take into account that if something goes wrong, your disaster recovery site becomes unusable. So in order to solve that, use the right tool for the right product. That means for Oracle databases, we choose Oracle Data Guard and Active Data Guard to protect your Oracle database from failures. How do we do that? We know what's in the memory and we know what's in the database block. We take that information and we send it in a synchronous or asynchronous way, which is the default, to the standby database, where it gets validated, and only when it's good, we apply it to the database, to the standby database. I've included some good links here that can help you to understand why Active Data Guard is a better choice than storage replication. So basically, as a recap, we have the primary database at the left, we have the disaster recovery center at the right, and basically all we do is we take the redo, we ship the redo, and we apply the redo. And that guarantees that you have always a standby database which is ready for use. At the bottom, you see the Data Guard broker, which is the preferred management mechanism for Oracle Data Guard. How does Data Guard work or sense its redo? Basically, we have three protection modes. We have the maximum performance mode at the bottom, which is the default. We have max availability and maximum protection. And all those protection modes differ in how hard you are protected against data loss. Maximum performance is asynchronous. That means that the primary is not waiting for the standby to confirm that the redo has arrived. It just goes on and on and on. What means that you can build up apply lag. There is a potential minimal data loss in this mode. And customers who don't want data loss at all, they often choose between max availability and maximum protection. The difference between them is that maximum availability can become unsynchronized. That means that we are stalling the primary until we have an acknowledgement from the standby, or that the timeout threshold expired. When the timeout expired, the standby becomes unsynchronized and waits for an archive log to arrive before it catches up, and then it catches up and it becomes synchronized again, and then you're in sync again. The difference with maximum protection is that we are stalling the primary or even shut it down when we don't have an acknowledgement from any replica. So in order to read more about this, because this is a very big topic, we have some good links about redo apply best practices for synchronous and asynchronous redo transport. But what I would like to highlight here is that we also have a MOS node at the bottom with or a TCP test tool that shows how you can calculate the network bandwidth for transfer of redo in Data Guard environments. Another thing which Data Guard is used a lot for is for planned maintenance operations. So first thing is that we can do standby first patching. Not all patches are eligible for standby first, and that's what you can read in the MOS node at the bottom. Usually PSUs, critical patch updates, Exadata bundle patches, etc., they are usually standby first. Another thing you can do for plant maintenance is a transient logical standby, which we will cover later in the presentation as well. In very short, we have a physical standby, we convert it to logical, do the upgrade on logical, and then do the whole switch. That's very short. And of course, you can do also migrations using Data Guard. If you want to move your data away from an old server and move to a new, or you want to do cross-platform combinations, and currently there is no NDNS compatibility. We cannot do from big to little endian or vice versa. That's not there. Let's see how the transient logical standby works or the rolling upgrade works. Basically, first what you are doing is you install a new version in each location, in database A and database B. Then we are going to upgrade or perform other maintenance on B, and then we are switching. We perform a role transition, and that leads to that the database A gets synchronized just via the redo stream, because database B was upgraded already. When we do a role transition, database A catches up. So let's see how that works in detail for a transient logical standby. This is the manual way. This is not a DBMS rolling. DBMS rolling makes this even a lot easier, and we will cover that a little bit later. But this is basically what needs to be done. I've also included a link to my blog at the bottom that gives you a walkthrough on how this process works. So basically what we are going to do is create a guaranteed restore point, build a logminer dictionary, and we need to do that to convert the physical standby database in a logical standby. And this is where DBMS rolling becomes important, and the manual way is less preferred, let me put it that way, because logical standby is a logical standby. Even though it's a transient logical standby, it has less support for certain data types. But you can do this completely manually if you want, but we recommend you to use DBMS rolling, which we cover later. The moment it's a logical standby, you can perform the upgrade. We have very good colleagues with very good blogs like Mike Dietrich and Daniel over by Hansen, which tell you everything about upgrading your database. So I would recommend you to follow those steps to upgrade the logical standby database. At that point in time, when you have your logical standby running in the new version, you perform a role transition so that the logical standby becomes the primary database. That means that the old primary database is now a logical standby. That's the next step. We have to convert it to a physical standby again. And that means that it's going to receive the redo from the new primary database on the site on the bottom. And that means that you have received the upgrade via redo. The 10th step, the last step, is actually optional. You can switch back, but this is how you do a minimal downtime upgrade using a transient logical standby in a manual way. Take into account it's a logical standby and not everything, not all data types are supported. Of course, we have some links for that as well. We have the Mosnet, which I mentioned before. We have also a link to the documentation on how to perform plant maintenance. Then let's see what Active Data Guard adds to you. So Active Data Guard is basically a lot more than just your read-only database. Let's see how that works. So basically this is Oracle Data Guard. It's the same slide as before, but when we add Active Data Guard, all this and even more comes with it. So let's dig into those features. A few use cases for Active Data Guard are, of course, normal disaster recovery, high availability, manual of automatic failover. Automatic failover is done using fast start failover. This is also there in Data Guard, but the primary copy disaster recovery, when you open it read-only and your redo gets applied, that's the second scenario. Then we are speaking about Active Data Guard. This is where a lot of people know Active Data Guard from. Snapshot standby is something you also could do. Snapshot standby is a physical standby that you stop the redo apply, that you open the physical standby in read-write mode. You do whatever you want in the database. You can test your upgrade script. You can test application scripts. You can test everything in a read-write fashion on your standby database. And afterwards, you convert it back to a physical standby database and it catches up with the redo it received in the meantime from the primary database. This has a huge advantage because you don't need to do extra copies of your databases. You just use the copy which is there, which is guaranteed to be an exact replica of the primary database at that given point in time. Pretty useful. Also in Active Data Guard, you can do database rolling maintenance, which is DBMS rolling, which we cover a little bit later. Also, you can use it for offloading your ARMA backups. And offloading ARMA backups means that you put less stress on your primary database, which can handle more load at that point in time. Something which is very interesting is that you also could use Oracle Active Data Guard standby databases as the source for your extract of Golden Gate. That means that you don't have to mine your primary database. And why should you? Because the active standby database is an exact copy of the primary database. Pretty useful to offload your workload to the standby side. And of course, regarding redo, we have FARSync and the CLRA. Okay, I'm convinced. Active Data Guard, how do you enable it? It's very, very simple to enable. When you have the Data Guard broker enabled, it's just you're opening your database. That's it. Nothing more, nothing less. If you chose for not configuring the database properly, you have to stop the managed recovery, open it, and then start recovery again. So basically, it's just included in the binaries. You just have to open the database, that's all. Okay, the zero data loss challenge. Remember that I talked about zero data loss, that it's something which customers really would like to have, but we have a challenge over there. The only way you can be sure that you have zero data loss is that when the commit happens, the standby acknowledge that the commit has happened. And you start feeling that this might become an interesting situation when primary and standby are very far out of each other. So to resolve that, we came up with the FARSync instance. That means a FARSync instance is a very small instance. It has no database files. It's not doing any media recovery. It's kind of a store and forward mechanism for Oracle Redo. You preferably put the FARSync instance in a third location close to the primary data center. Why a third location? Because you need to talk between primary and FARSync, you need to talk synchronous. The further away from the primary database, the more performance impact you have on your primary database. So if you put the FARSync instance in the same data center, yeah, it's not a lot of use to put it there, because if you lose the data center, yeah, you lose the FARSync as well. So put it outside of the primary data center, but close enough that the synchronous communication between primary and FARSync does not impact performance. The moment the redo has been acknowledged, because it's synchronous, acknowledged to the primary, this FARSync is going to send the redo in an asynchronous way to the standby database. That guarantees zero data loss. The switchover, you don't need to do anything special for a switchover. The commands stay the same. It's completely transparent. You just issue the switchover just like you would have done before without the FARSync. A failover is more interesting, because what happens with a failover, suppose that you lost your primary database. The standby database knows where it gets its redo from, and that's combined in redo routes and defined in redo routes. So the standby knows where the redo is coming from, and in this case, the redo is coming from the FARSync instance, not directly from the primary database. So the moment you need to do a failover, the standby asks to the redo source, in this case the FARSync, hey FARSync, do you still have some redo for me? And of course, usually it has, because it has up to the latest commit, because it's in synchronous mode with the primary database. FARSync says, yes, standby database, I have some redo, here you have it, and the FARSync sends the very last redo to the standby database where it gets applied, and only then the role transition is performed, and the standby becomes primary at that point. It's very useful. So I have also included some good white papers here about zero data loss at any distance. And also I have included the blog post, which is telling you about redo routes, priorities, and even some alternates, because what happens when the FARSync fails? You can specify an alternate FARSync. So that includes that you are going to make sure that also your FARSync instance is protected with an alternate FARSync instance. Another cool feature from Active Data Guard is basically the automatic block repair. So Oracle will detect if a block is corrupt at the primary. At that point in time, we are fetching the good block from the standby database and apply it to the primary without the application noticing it. And that brings us to some applications. When you have Active Data Guard, you can also use application continuity. So imagine when the primary database fails, what we are going to do is that we are going to fail over either manually or automatic with fast start failovers to the standby database. At the standby database, we are going to start the services automatically, and we are going to inform which fan events to the application server that the standby became primary. The next step for Active Data Guard, and this is where it gets very interesting, is DBMS rolling. So instead of all the steps contained in the transient logical standby, you just do start, switch over, finish. That's simple. So DBMS rolling is a PL SQL package which replaces all those manual steps. And yes, remember, it's a lot of steps. Also, something very good in DBMS rolling is that, yes, we are still using the transient logical standby database, but we are also protecting you from the unsupported objects. So we have views in the database related to DBMS rolling that inform you about unsupported objects. If you are hitting or using those unsupported objects during the upgrade of your transient logical standby database, we will inform you. And yes, you will derive from primary standby because we are blocking access to those objects. So if you are touching those objects during the upgrade on the primary database, yes, they will not be replicated on the logical standby database. But at least we inform you so that after the role transition, you can fix only those objects which will give you a lot of benefit in time. So you don't have an outage due to that. Let's see how it works. Basically, in the documentation, we have added 2 extra steps. So I said start, switch, finish. Yes, that's true, but step 2 and 4 are the pending steps. So basically what we are going to do is that we are going to start a plan, and then we are going to convert with a very simple DBMS rolling start plan. We are also going to convert the physical standby database in a logical standby database. We also put the guaranteed restore points for you. So we do all those steps automatically, and we list them in DBA underscore views. At step 3, that's the moment where your outage is happening. So we are doing the DBMS rolling dot switchover procedure, and that does the role transition completely automatically. Then you have upgraded your database and you are running on an upgraded database. That only takes a couple of minutes. In step 4, of course, you need to do a manual step because we cannot determine where the new Oracle home will be. So you need to start up the former primary, the new logical standby on the original server from the new Oracle home. And then we finish the plan in step 5, and that converts the logical standby again in a physical standby. And basically then you're ready. Then everything is done. So you see, it's a safe, easy way to upgrade your database with minimal amount of downtime. As you would expect it, we have some PDFs and documentation about that as well. And we even have a 12C demo online. And I have also a blog post on my blog about DBMS rolling, how it works, and the more detailed description of what I just said. So this leads us to new features. In Oracle Data Guard 19c, we also have some new features. And let's dig into them one by one. The first one is a Flashback Database Enhancement. Imagine the application upgrade. You put your restore point in the primary database, and your primary database breaks for any reason you can imagine, and you have to fail over to your standby database. But it was in the middle of the upgrade. So that means that your standby that became primary is logically corrupt. That's basically not something you want. To resolve that issue, we have introduced a new feature, and that is basically that we are going to propagate all the restore points automatically to the standby. We have enhanced the VDOL restore point view for that, so that you can distinguish which restore points are replicated from the primary. And also we are suffixing those restore points with the underscore primary on the standby, so that you can distinguish the restore points which you had created earlier on the standby and which are coming from the primary. Let's see how that works. So this, in the top, we have the primary database. In the bottom, we have the standby database. So we are going to query that you can see that. So There we have the standby database is a physical standby. Of course, we have to check if there are already some restore points. So we are checking in the VDOL restore point view, and we don't have any restore points in the primary database. And we will do the same check in the standby database. There we see that there are no restore points at all. Next step is to create a restore point, a guaranteed restore point in the primary database, which is called test RP. And then we are checking if it has been created, yes or not. So we have it in the primary database, and now we are going to check the standby database. And there you can see, after querying VDOL restore point, that it has been replicated and it has been suffixed with _primary, and the column replicated is put to yes. And it goes without saying, of course, that when you drop the restore point on the primary database, that it cleans up automatically on the standby database as well. So it's gone on the primary database, and let's check on the standby database as well. There we see that it's gone as well. This is the restore point propagation. Another Flashback database enhancement is that standbys automatically follow the primary database after a resetlog operation. In the past, when the primary database was doing a resetlog operation, that means that it gets a new incarnation. That has not changed. It's still a new incarnation. But the standby database now notice that the primary database has a new incarnation. And the only thing that you need to do for this mechanism to happen is that you have to specify that you the DB Flashback retention target and put it at a higher value, or at least the same value as the primary database. And what will happen when the standby notices it? It sees, oh, I cannot receive a redo anymore from the primary database, so I'm going to flashback as well, which of course leads to a new incarnation for the standby database, and then it catches up with the primary database and follows automatically. The only thing you as a DBA need to do is, when you are running in real-time apply, so Active Data Guard enabled, you need to shut the standby database down and start it up in mount, and then the whole process kicks in. The moment the standby database is in sync again, you can just open the database again in read-only mode, just like you used to. Another enhancement that we have now that reporting becomes very attractive on the standby database is that we have implemented REC support for the buffer cache preservation feature, which we introduced in 18C. Buffer cache preservation means that the moment we do a role transition, we are trying to keep the buffer cache in memory from the standby database. So, of course, when we have to restart the database, yeah, we cannot preserve it. But the moment we don't have to restart the database to open it, then the buffer cache is preserved also in REC at this point in time. And that brings us to REC. So when you have a REC database with, for instance, 3 instances, and you have a standby database with also 3 instances, that by default, we are going to use only one instance, which we call the apply instance. And that's also what we call single instance redo apply. Even if your primary database has 3 instances, your standby database has also 3 instances, we are by default only going to use 1. You can imagine that some customers with really high redo rates, sometimes lag behind on the standby database. To solve that, we have introduced in 12.2 multi-instance redo apply. And what will happen then is that the MRP processes will be started on each node. And we have a coordinator process, which is telling the instances which redo to apply. So thread 1 will send a redo to thread 1, thread 2 to 2, 3 to 3, etc., etc. And we are improving this technology every single release. So here you see that we are also introduced it with 12.2, and in 19C, we also make sure that the memory column store works with multi-instance redo apply. And that brings us to the in-memory column store. So in-memory database can be activated on Active Data Guard. So you can create your IMC tables also on your standby database. And the cool thing is that you can populate them with different data than your production database. And how do you do that? Basically, you just set it in memory and distribute for service, and you have the alter table and alter statements ready, and they can differ between primary and standby. Another cool feature, and this is basically the key feature of Data Guard 19C, is DML on EDG, or also known as DML redirection. Don't get me wrong, the standby database stays a read-only database just like you're used to. But the difference in 19C is that we are allowing you to do occasional DML against the active standby database. By default, it just returns read-only database, but when you set a parameter alter session or system ADG redirect DML, then the standby database knows that the moment DML is issued against the standby database, it has to forward it to the primary database. On the primary database, it arrives as a very normal transaction, and it has an own SCN and everything. So even at that point in time, you would cut the connection between primary and standby, the transaction has arrived on the primary, and it stays consistent. So it's fully ACID compliant. The moment the transaction, DML, is issued against primary database, it generates redo. Redo is sent to the standby. And then the lock is resolved, and then data is visible to the customer. So that means when you take that into account, that we targeted this function for read mostly occasional update applications like reporting applications in general. Because reporting applications usually do 95% select, and then they need to flag, oh, this report has been run, or they need to have some table access which they are writing some intermediate results. And that's where this feature has been designed for. Okay, let's see how this works. In the top, we have the primary database. In the bottom, we have the standby database. And of course, they are set up Active Data Guard, and we have a result from a certain table, from the customer's table. And as it's an Active Data Guard database, we can select from the standby database, and we have, of course, the same result there. Then we are going to try to do an insert on the primary database, which of course succeeds. And then you have to commit it to make it persistent and go to the standby database. And we will try the same on the standby database, which fails by default because it's open for read-only access. When we then set the ADG redirect DML parameter, and we do that on session level here, there we go. And we try the insert again, then you will see that it succeeds. And then when you commit it, there we go. Then it's visible also at the primary side and at the standby side. They are consistent. So, and this is basically ADG redirect DML feature. As I told before in the session, the preferred way to manage your standby database is the Data Guard broker. So yes, we do have some improvements there as well. Let's see what we came up with in 19C for the Data Guard broker. So the first thing is that in 18C, we had the debug qualifier as a trace level. Yeah, it's not very user-friendly. We changed that to support. It's not a huge change, but it's an important change because by default, we are running in trace level user, which tells you just, I'm connected to the database, or just not very verbose in the broker. When you put it on support, it tells you every single little step it does. So let's compare the two. So when at the left, we have the user, which is the default, and at the right, we have the support version. From exactly the same command, I had to scale down the font for the right because it's pretty verbose, as you can see. So, but in the left, if you say connect slash, it just tells you, okay, I'm connected to this database and I'm connected as sysdg. If we do exactly the same connect command, but set the trace level to support, it tells you every single little step it takes. It goes to connecting to the database, executing queries, query results, it gets back. And imagine when you have a failed switchover, how useful this can be. By default, it only says, yeah, okay, failed switchover, primary database is that one, the standby database is that one, and done. If you set your trace level to support, and in combination with the DRC log files, we enhanced the verbosity of the broker a lot. So that's easy to see where your failures come from. Also, if you open a service request regarding failed switchovers or broker issues, send the trace level support also with your service request. It will help the engineers a lot. DBAs love to be in control, and they should. And that's why they might be interested in the observe only mode, because nobody wants an unexpected failover. And fast start failover means that we are going to fail over your database to the standby database when we can do it without data loss, but also when we think when it needs to be done, when not we, the observer actually. In order to improve that and to give you the opportunity to tune your parameters very well, we included the observe only mode. And basically it's just fast start failover, but we will just tell you that the failover would have happened. We will not do it. We will just put in the log files. In this case, the failover, the automatic failover would have happened. That's useful to see if you have unplanned failovers or false positives. If you have false positives, it gives you the occasion to tune your FSFO properties more precisely. And fast start failover properties can be a corrupted control file. It can be an OR error that you have defined yourself. It can be a corrupted dictionary or that kind of stuff. But to observe, to test fast start failover and to see if it runs well in your environment, you can now use the observe only mode. When you're happy with the results after a while, you can disable fast start failover and then enable it again without the observe only clauses. And then no false positives are expected to happen. Another manageability thing that we have added is in the past, you needed to ask every single database separately, hey database, how far are you behind? In 19C, we added the show configuration lag command, which tells you the lag, transport lag, and apply lag for every single member in the configuration. I think that's pretty useful. And as you have discovered, the broker becomes more and more important. So what we did is we added some export and import features so that you can back up your broker configuration file. So it's an XML file. You don't need to name it XML, but it's useful when you do. And that file is in the same location as the DRC log and the alert log file from the database. The cool thing is you can just edit it. And when you import it with edited data, you can use it for fleet provisioning and patching. And this was the end of the presentation. So I would like to open up for questions and answers. Thank you very much.